All right.
Oh, we eat.
Math sustains us, Brendan.
Got it.
We don't need food when we have math. All right, so here we go. This is practice test number 2. And oh my goodness, we are starting with what we just finished with.
Oh my goodness.
So we're starting with these 2 functions. And I don't want you to be confused by the letters. F and G, A and B, M and N doesn't make a bit of difference. Functions can be named whatever. First one. All right, so just stop a minute. We just did this. We're going to figure out what n of x is. Well, we know what n of x is. It's x squared plus 2, right? And then what are we going to do with that x squared plus 2? We're going to go to the m function and plug it in right there. So we'll have 4 x squared plus 2 minus 3, which is 4x squared plus 8 minus 3, which is 4x squared plus 5.
Yes.
And again, you're going to want, some of you are going to want to do something with that. Don't. Just stop. That's the answer.
Okay.
What?
Oh, I was checking my answer.
Okay. All right, now the second one says m of 2 minus n of 3. Don't be confused. It's a 2-step problem. We'll start by doing what?
Plugging in 2 for n.
Putting 2 in here. So m of 2 is what? If I put 2 in there, I get 8 minus 3. I get 5?
Yeah.
Got it?
Got it.
Now I'm putting 3 into n. So 3 into n would give me 11. Now what am I supposed to do with those 2 answers? Subtract them. So the answer is negative 6. All right, here we go. This is another composition, so slow yourself down. Start by putting 1 into n. So 1 into n, put 1 in here, would give you 3. Then take the 3 and put it into m. So 3 into m would give us 9, and that's the final answer. D says multiply m of x times n of x. So that's multiply 4x minus 3 times x squared plus 2. We're not plugging anything into anything. We're simply multiplying. The last one I think we subtracted. You can do whatever operation. So this is going to be a FOIL. So 4x cubed minus 3x squared plus 8x minus 6. I think that actually came out in descending order, so I think I'm good. And again, don't do anything. Don't try to factor or do anything weird. Just stop. That's the answer. Okay? So speaking of stopping, these we sometimes get carried away with too. Don't get carried away. You're finding the implicit functions. So we got y by itself. So we'll subtract
Negative
the 2x squared.
That's it. And then get squared.
And then we will square root and write 2 separate equations that are the ones I put into my calculator if I were graphing. Y equals the square root of 6 minus 2x squared, and y equals the negative square root. And where does the negative sign go?
In front of the square root.
Outside the radical. Don't put it inside. And are we going to simplify that?
No.
No matter what the numbers are. So if you see a 9 or a 16, I don't care. It doesn't simplify, so don't do it. No. Negative 2x squared plus 6 is the same thing.
So it's gonna have
Yes, no, they're the same thing. Addition is equal. All right. Now, part 3. Now we got our domain questions. All right, so here we go. What's the domain of these guys? What do you think?
y is greater than or equal to 1.
X is greater than or equal to
Oh,
1. Why is that the domain? What is my logic, or what was his logic on that?
The radical rule.
The radical. Stop right there. The radical. We know whatever is under the radical must be bigger than or equal to 0. So X has to be bigger than or equal to 1. Now, text. This problem has no radical, so I don't need to worry about that.
Right.
What do I have to worry about?
What about the other rule?
What is the other rule?
The bottom can't be zero.
Exactly. So the bottom, or the denominator, cannot be 0, which means that 3x cannot be 1, and x cannot be 1/3. That's your domain. Right, Ashley? Okay. Domain. All reals. Or if you prefer, you can write this interval. We talked about that earlier, doesn't matter. And the last one. Now what's going to happen here when I do this problem? I'm going to have 2 answers. And the reason that I'm going to have 2 answers is because I have both issues, right? So what does the radical, what's that radical rule again, Sam? What's the radical rule?
X is greater than, or I guess negative 1.
Right, whatever is underneath is greater than or equal to 0, so X is going to be bigger than or equal to negative 2 in this problem. Yep. Maddie, what's the other rule?
The bottom can equal
The bottom cannot equal 0, so X cannot equal 3. And we write both of those in the answer blank. Right? Okay, rolling on. Here we go. Now we're going to do some sketching. This is exactly what your test looks like, guys. So you're going to have to do some sketching here. What shape is that? It's a V. The normal V comes out from the origin. This one isn't. This one's going to come out from where?
Negative 1.
Negative 2, positive 1. Because this moves me to left, and that moves me up 1. Now we had one of these on the other test. This is probably the trickiest question on the whole test. This is a sine function. And it's not hard, but you have to remember that the normal sign, I'm going to graph it in blue, the normal sign goes up and down 1. So it has a hill that goes up 1 and a valley that goes down 1, and so on. This is the normal sign. Okay? Now, what's going to happen to this blue thing here? What am I going to do with it?
Move it up 2.
Move it up 2. There's no parentheses, so it's not a sideways move. I'm going up 2, which means, see how it was going between -1 and 1 before? If I move it up 2, now it's going to be going between 1 and 3. Now, if it helps you, you can go ahead and put your axis right here. See how that's the axis? And then you can make your hills and valleys across that, if that helps you. You see what I did? Instead of being 0, my oscillation line is 0. I moved it up to 2. And then I oscillated between 3 and 1. Now, if all you have on your test paper is a squiggly line, you're probably not going to get very much credit. You have to be a little bit careful when you graph these. All right, that's the hardest one. The rest of these aren't too bad. What's C? What shape is C?
Parabola.
It's a parabola. And the normal, how do we know it's a parabola?
Square function.
Squared, yep, squaring function. The normal parabola starts at the origin. Where's this one starting? Shiloh, you awake, Angel? Okay. Where's it starting? Right 1 and down 1?
Yes.
Right inside the parentheses, down outside the parentheses. There it is. What do we have here? It's a cubing function, and the normal cube squiggles through the origin, right?
Yes.
What's happening to this one? Left 2. So that squiggle point now is over here at -2. Shiloh?
The way the squiggle is ever flip, how it always goes right.
Yes. Only if we start with negatives in, which we will do in the next part of the chapter. Right now, there is going to be that direction. And then we've got this one. All right, so what shape is this? It's your square root function, which some of you just took a quiz over that. It looks like that, right? Where is this not the origin now? Where is this starting point going to be?
-1.
-1, -2. Okay, these are some of the things we have to remember. That means left. That means down. And then our shape. We're doing amazingly well.
We're on F now.
We need to do our piecewise function now. We have one more to graph, our piecewise. All right, so who remembers the strategy for this? This one's going to be worth a little bit more than the other graphs because it's a little more involved. Brendan?
So I started with the top one, and so I realized that that's the identity,
Okay.
and so I just graphed that line from the.
Okay. Before I do that, I'm putting in my break line here. You don't need to do this. It's not part of the picture, but it helps me keep my points lined up, so I'm going to go ahead and do that. Brendan says this is a line. Y equals 3x minus 4 is a line. Right? Tell me about that line. It has a y-intercept at -4, 1, 2, 3, 4. And it has a slope of
3.
3. So up 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. Now those are supposed to be in a straight line. I'm not very good at this. Missed that one, but there we go. So here's my line.
And then you're gonna put an open circle.
And it
where
breaks
possible.
right here, right?
And then you're gonna want everything bigger than -1. So
And
you're
that's
gonna
going to
take.
be open.
You want everything bigger than -1. Oh no, you want -1 to be bigger than everything else. So you're
Yeah,
gonna take the left.
so I want to keep the left, right? So all this lovely line I'm going to erase now. So far, you can barely see it. All I have is this thing down here. Right? Okay. Now, I need to do this other piece. All right, so what is it? What shape is this going to be? It's our V, but it's an up one V. It's over here now.
Yep.
And it crosses right here.
Closer.
And that dot's going to be closed.
And then on that one, you want everything bigger than that.
And on that one, I want the right side, so I'm going to erase this side. We're all going to get this right? One step at a time, it's not hard. Notice my dots are lined up on top of each other. Always will be if you've done it right. Okay. One more part of the test. This is the vertical, horizontal, and holes. Easy. First of all, there are no holes. How do I know?
Nothing cancels.
Nothing cancels. If you can't cancel, you're not going to have any holes, period. What can you tell me about vertical asymptotes? Where do they come
Come from
from?
your domain rules.
From the domain rules. They come from the denominator, right? Tell me what x cannot be.
4/3.
X cannot be 4/3.
Yep.
So my vertical asymptote is at 4/3. Your vertical asymptote is where x cannot be. Now what about horizontal?
They come from
The box, right? We make the box. And this is an easy one. When I box that in, I get y equals 2/3. That one's easy. All right, next. If you see factoring, you should probably do it just in case things will cancel.
but they don't.
They don't. And if you can see that, it's okay. But I'm going to go ahead and factor it because I want you to get in a habit of at least checking it. Nothing canceled. So what does that mean? Once again,
No holes.
no holes. Nothing canceled.
You're gonna have a
What can x not be? Where is my vertical asymptote?
-5.
-5. Because if x is -5, your denominator is 0, and that is not allowed. Now what about the horizontal asymptote?
Oh,
This
you're
is
gonna
where
get
it gets a little
none.
tricky.
No.
Well, this is you have a 1x squared on the top, right? But I don't have any x squareds on the bottom, so I have to put that 0 in.
Can't spell an X.
And when I do that, I get 1/0. None. Can I have 1/0?
You can't spell an
No, 1/0 is none. What's 0/1? If we had a problem where we got 0/1, that would be 0. But I have 1/0, none. see if we can get this last one done, and then we will be finished. Burkhart or Logan or whoever was back there asking about it. All right, what do we do with this guy?
Factor.
Factor. Factor everything you can factor.
X squared.
How does the top factor?
X plus 4, X minus 4.
The top factors by taking out a 2,
Duh.
And then you could do X plus 4.
and then we have X plus 4, X minus 4. Everybody keeping up with that?
Yeah.
Okay. What about the bottom?
X minus 4, X plus 5.
X minus 4, X plus 5. Is Sam correct?
Yeah.
Yes. That means that we can cancel. Uh-oh. That means that we're going to have a hole, a removable discontinuity, a hole. Okay? Now, the hole is a point, an X and a Y. What will the X be? Pay attention to what you canceled out. The X will be
4.
positive 4. The X is the opposite of whatever you canceled out. So if you cancel out X minus 4, it's a 4. Now, the Y comes from here.
So it'll be 2.
So I put 2 in for the X's.
Oh, wait, what?
Kids, this is your new equation right here. If you know X, you just plug it in to find Y. So I'm plugging in, or I gotta plug in 2,
Put in 2.
because I'm a youth ball. I gotta plug in 4. Thank you. I gotta plug in 4. So I put 4 in for my X's. Thank you. So what do I end up with? 2 times 8 over 9. Did you get 16 over 9?
Yeah.
That's my Y coordinate.
Can we not factor?
That must be.
We not able
Wait.
to.
Where's our vertical asymptote?
Negative 5.
Very good. X equals negative 5.
I got negative 2.
My horizontal asymptote is Y equals 2. Very good. Okay. So, next time we are together, we will do practice test 3. We will answer whatever questions you